Picture a forest floor in northern Michigan sometime around 1870. The ground is frozen solid. Your breath hangs in the air like smoke, and somewhere ahead of you, buried in 3 feet of snow, lies a white pine log that weighs more than a locomotive. The log is 60 feet long and 4 feet across at the base. It took 6 men with crosscut saws 3 days to bring this tree down, and now it needs to move. It needs to travel 2 miles, through dense timber, across frozen swamps, and down a skid road carved through virgin forest to reach the riverbank where it will wait for spring. The only way to move it is with oxen, and you're going to need a lot of them. 40 oxen stand in the cold, their breath rising in clouds, their massive bodies steaming in the December air. 20 teams of 2, chained together in a line that stretches back nearly 100 feet. Each ox weighs close to 2,000 pounds. Together, this wall of muscle and bone represents 80,000 pounds of pulling power, and it still might not be enough. The teamster, a man named William, has been doing this work for 11 years. His hands are permanently calloused. His back aches in ways that will never heal. He has seen men crushed by rolling logs. He has seen oxen break their legs in hidden ravines and have to be shot where they fell. He has buried 3 friends in unmarked graves cut into the frozen ground of lumber camps. But this is how logs move. This is how America builds its cities. And there is no other way. Except there will be. In just a few years, a blacksmith in Manistee, Michigan, will build something that changes everything. A contraption so simple in concept and so radical in application that it will make 40 oxen obsolete overnight. He will build the biggest wheels the world has ever seen. And nothing in the logging industry will ever be the same. This is the story of how 30-ton iron wheels replaced 100 oxen, transformed an industry, and wrote a forgotten chapter in the building of America. To understand why these wheels mattered, you first have to understand what logging looked like before they existed. And I mean really understand it. Not the sanitized version you might picture, with lumberjacks and flannel shirts swinging axes like some kind of romantic frontier postcard. The real version. Like the version that killed men by the thousands and worked animals to death by the tens of thousands. The Lake States region of America in the mid-1800s contained the largest concentration of white pine timber in the world. Michigan, Wisconsin, and Minnesota held forests so vast and so dense that the first European explorers described them as endless. Trees that had been growing for 300 years. Trees so large that a man could stand inside the hollow of a fallen trunk. Trees worth fortunes. And all of it standing in wilderness, without roads or railroads or infrastructure of any kind. Just millions of acres of virgin timber waiting for anyone who could figure out how to get it out. The scale of these forests was almost incomprehensible to the men who first saw them. Surveyors sent to map the territory reported walking for days without seeing sunlight through the canopy. The trees grew so close together and so tall that the forest floor existed in permanent twilight. Moss covered everything. The silence was oppressive, broken only by wind in the upper branches and the occasional crash of a falling limb. The men who came to cut these trees understood something that we have largely forgotten. They understood that the logging itself, the actual felling of the trees, was only part of the problem. In some ways, it was the easy part. A crew of experienced sawyers with sharp tools could bring down a massive pine in a single day. The real challenge, the thing that limited how much timber could actually reach market, was transportation. The trees were worth nothing standing in the forest. They had to reach the sawmills. The sawmills had to be on navigable water, and the distance between the trees and the water might be 5 miles or 10 miles or 20 miles of trackless wilderness. Before the big wheels arrived, moving timber from where it fell to where it needed to go was arguably the hardest job in the entire lumber industry. Harder than felling the trees, harder than sawing them into lengths. The moving was what broke men and beasts alike. Here is how it worked. When a tree came down, a crew of sawyers would buck it into manageable lengths, usually 16 to 20 feet, depending on what the mill could handle. Each section still weighed tons. A single 16-foot log from a mature white pine could weigh 5,000 pounds or more. Some of the giants, the truly massive old-growth specimens, produced sections weighing 12,000 pounds. 12,000 pounds. That is the weight of 3 automobiles, concentrated in a single wooden cylinder lying on a forest floor covered with snow and brush and the debris of a century of growth. Now you had to drag these things out of the forest. The primary method was something called skidding. You wrapped chains around the log, hitched those chains to a team of oxen or horses, and pulled. The log dragged along the ground, gouging trenches into the earth, catching on stumps, hanging up on rocks, and generally fighting you every inch of the way. The friction was tremendous. A 5,000-pound log dragging across bare ground might require 8 oxen to move. Across wet ground or mud, you might need 12. Across snow and ice, the friction dropped. But so did your control. Logs on icy skid roads had a tendency to gain momentum and crush whatever was in front of them. This was why logging in the Lake States was almost exclusively a winter operation. The frozen ground could support the weight of heavy equipment. Snow and ice reduced friction enough to make skidding practical. And most importantly, the rivers and streams were frozen, which meant you could not yet float logs to the mills. The winter was for getting logs to the riverbank. The spring, when the ice broke up, was for driving them downstream. To reduce friction, logging crews built skid roads. These were paths cleared through the forest, with logs laid crosswise every few feet to create a kind of crude railway. The dragged logs would ride over these skids, reducing ground contact. It helped. But it also meant building miles of road through wilderness just to extract timber. Think about what that required. Before you could move a single log to market, you had to send crews into the forest to clear the path. They felled trees not for lumber, but just to get them out of the way. They grubbed out stumps. They filled ravines with brush and logs to create level crossings. They laid hundreds of skid poles, cutting them to length, positioning them at the right spacing, replacing them when they rotted or broke. A well-built skid road might have crosspieces every 8 to 10 feet along its entire length. A mile of road required more than 500 individual skids to be cut, hauled, and positioned. A major logging operation might need 10 or 15 miles of skid roads to connect their cutting areas to the river landing. The skid road construction alone might take weeks, and the roads only lasted one season before the spring thaw turned them into impassable mud. Every autumn, the whole process started over. New crews went into the forest. New roads were cut. New skids were laid. The infrastructure of extraction had to be rebuilt every year. And the animals. God, the animals. Oxen were preferred in the early days because they were stronger and steadier than horses. A good ox team could pull for hours without panic. They could work through conditions that would have terrified a horse. They did not require the expensive grain that horses needed to maintain their condition. They could survive on hay and browse that cost almost nothing. And when they died, which they did frequently, their meat could at least feed the camp. But oxen were slow. Agonizingly slow. A loaded ox team might cover 2 miles per hour on a good skid road. In rough terrain, you were lucky to make half a mile in an hour. The mathematics of this were brutal. A camp located 5 miles from the river landing might need an entire day to make a round trip with a single log. The ox drivers, called bullwhackers, walked beside their teams for miles every day. They carried long poles with metal tips called goads, which they used to direct and encourage the oxen. A good bullwhacker knew his animals by name. He knew their individual temperaments. He knew which ones would pull steadily and which ones tended to balk. He knew how to read the subtle signs that told him an ox was tiring or injured. The work destroyed them. An ox used for logging might last 2 or 3 seasons before breaking down. Their hooves cracked on frozen ground. Their legs gave out from the constant strain. They developed open sores where the yoke rubbed their necks raw. The constant effort of dragging multi-ton loads day after day simply used them up. And when they could no longer work, they were slaughtered for meat to feed the very camps that had used them up. Their hides were tanned for leather. Their bones were boiled for glue. Every part of them was consumed one way or another. The camps required enormous quantities of oxen. A large operation might maintain 100 or more, with replacements arriving every season to fill the gaps left by death and disability. Some estimates suggest that Michigan logging operations alone consumed more than 15,000 oxen per year during the peak of the lumber boom. The entire agricultural economy of the upper Midwest was shaped in part by the need to breed and supply draft animals for the lumber industry. Farmers throughout Ohio, Indiana, and Illinois raised oxen specifically to sell to the logging camps. So there were dealers who did nothing but buy young cattle in the South and drive them north to the timber country. It was its own economy within the larger economy, and it consumed animals at a rate that seems almost industrial. Horses were faster, but more nervous. They spooked at falling trees and rolling logs. They required better feed that had to be hauled into remote camps at considerable expense. And they died in the woods at rates that would horrify anyone today. A horse that stumbled on a skid road might break a leg and have to be shot where it fell. A horse that panicked during loading might kick itself free of the traces and run into the forest, never to be seen again. A horse worked too hard in extreme cold might collapse from exhaustion and freeze to death overnight. Some estimates suggest that logging operations in the Lake States killed more horses in a single decade than the Civil War did in 4 years. The exact numbers are impossible to verify because nobody was keeping careful records of animal deaths. They were just part of the cost of doing business. You could walk through any major logging operation and find the carcasses of draft animals left where they fell. Sometimes they were butchered for meat. Often they were simply abandoned, too far from camp to be worth retrieving. The wolves and ravens would clean them up by spring. This was the world that existed when Silas Overpack opened his blacksmith shop in Manistee, Michigan in 1874. A world where the only answer to moving heavy timber was more animals, more men, more suffering. A world where the limiting factor on how much lumber could reach market was not how fast you could cut trees, but how fast you could drag them out of the forest. Overpack was not a logger. This matters. He was a blacksmith who made his living building and repairing equipment for the lumber camps that surrounded his town. He built chains, he repaired yokes, he fabricated the metal components of sleds and wagons, and day after day, he watched logging crews struggle to move timber that seemed almost impossibly heavy. Manistee in the 1870s was a lumber town through and through. The river that gave the town its name ran thick with logs every spring, on millions of board feet floating down to the mills that lined the waterfront. The sound of the mills was constant, a grinding roar that you could hear from anywhere in town. Sawdust filled the air. The smell of fresh-cut pine was inescapable. The economy of the entire region depended on getting timber from the forest to the river, and the entire system was straining under its own weight. The best stands of timber near the rivers had already been cut. The remaining trees were farther inland, and requiring longer skid roads and more animals and more time to reach. Overpack watched this struggle every day. Teams came into town with broken equipment. Chains snapped under loads they were never designed to carry, yokes splintered, wagon axles bent under weights they could not handle. And always, the problem was the same. The logs were too heavy to move efficiently. The problem, as Overpack saw it, was not a lack of pulling power. You could always chain together more oxen. The problem was friction. The problem was that logs dragged along the ground with their full weight pressing down, and no amount of muscle could change that fundamental physics. Imagine dragging a 50-pound sack of grain across a dirt floor. Hard work, but manageable. Now imagine dragging it across deep mud. Now imagine dragging it uphill. Now imagine the sack weighs 5,000 pounds. At some point, the friction exceeds anything that can overcome it. You can add more oxen, but there is a limit to how many you can chain together and still coordinate their movement. But what if the log did not drag? What if, instead of pulling the log along the ground, you could lift part of it into the air? This was not a new concept. For centuries, people had used simple wheeled carts to transport heavy loads. The wheel eliminated friction by replacing drag with roll. A man who could barely push a 100-pound weight across the ground could easily roll a 500-pound cart because the wheel changed the equation completely. But standard wagon wheels could not handle the weight of mature timber. They would shatter under 5,000 pounds, let alone 12,000. The wooden spokes would splinter, the iron tires would bend, the axles would snap. Everything about conventional wheel design assumed loads of hundreds of pounds, not thousands. Overpack's insight was that the wheels needed to be dramatically larger. Not just a little bigger, enormously bigger. Wheels so tall that they could lift the front end of a log high off the ground, distributing the weight across a massive axle, while the back end of the log dragged behind on a simple skid. The geometry of this was crucial. A 10-foot wheel rolling over rough ground would encounter fewer obstacles than a 3-foot wheel, because the larger wheel could simply roll over stumps and rocks that would stop a smaller one, and the larger wheel distributed its weight across a longer contact patch, reducing ground pressure and preventing the wheel from sinking into soft soil. Think of it this way. A standard wagon wheel might have a contact patch of a few square inches. All the weight of the load concentrated in that tiny area. A 10-foot wheel, with its much wider tire, might have a contact patch of 100 square inches or more. The same total weight spread across a much larger area meant much lower pressure at any single point. He started building his first prototype in 1875. The wheels were 10 feet in diameter, constructed from heavy oak with iron tires. Each wheel required the largest oak trees available, and with spokes cut from straight-grained heartwood that could withstand repeated impacts. The iron tires were 4 inches wide and half an inch thick, bent into circles by heating them red hot and hammering them around forms. The axle was forged steel, thick enough to support loads that would crush anything smaller. It weighed nearly 1,000 pounds on its own. The tongue extended forward, where a team of horses or oxen could be hitched. The design was brutally simple. You backed the wheels up to a log pile, lifted the front ends of several logs using a simple chain and lever mechanism, and secured them beneath the axle. The logs hung suspended, their front ends riding between the giant wheels, their back ends trailing on the ground, and then you pulled. The back ends of the logs still dragged, but now they carried only a fraction of the total weight. Perhaps a quarter of the total load rested on the dragging ends. The rest rode on the axle, rolling smoothly on those enormous wheels. The friction dropped dramatically. The pulling power required dropped with it. When Overpack tested his first big wheels in the winter of 1875, the results were almost unbelievable. A single pair of horses could now move logs that previously required 8 oxen. The wheels rolled smoothly over the rough terrain, carrying their burden through forests that would have swallowed a conventional wagon. 2 horses, 8 oxen, same load. The economics were staggering. It was not just the reduction in animals that mattered, it was the reduction in everything. Fewer animals meant less feed to haul into the camps. Less feed meant fewer wagons needed for supply. Fewer supply wagons meant fewer road-building crews. The savings cascaded through the entire operation. Word spread quickly through the lumber camps of northern Michigan. Within months, Overpack had orders for more wheels than he could build. He hired additional blacksmiths. He expanded his shop, and he began refining the design based on feedback from the teamsters who used them. The first generation of wheels had some problems. The wooden spokes, while heavy and strong, still cracked under repeated stress. The impact of rolling over stumps and rocks traveled up the spokes and concentrated at the hub, where failures occurred. The iron tires worked loose from the rims after bouncing over rough ground. The chain mechanisms for lifting logs were awkward and required too many men to operate efficiently. The second generation addressed these issues. Overpack built wheels 12 feet in diameter with reinforced spokes and heavier axles. He redesigned the chain system to use mechanical advantage more efficiently. He added features that the teamsters requested, like improved tongue connections and better braking surfaces. They could carry log loads approaching 10 tons. The third generation pushed to 14 feet. Some specialty wheels, built for the largest old-growth timber, reached 16 feet in diameter and weighed over 3 tons per wheel. These were the biggest wheels ever used for logging. Possibly the biggest wheels ever used for anything in American industry. And they worked. A teamster with a good pair of big wheels and a team of 4 horses could move more timber in a day than a 40-ox team could move in 3. The math was staggering. Or to one documented operation in 1882, recorded a single big wheel rig moving 63 logs in a single day, covering a total distance of nearly 20 miles. The same load, using traditional ox-powered skidding, would have required several days and vastly more animals. The cost savings were immediate and dramatic. An ox team required enormous amounts of feed. Hay and grain had to be hauled into remote camps at considerable expense. A single ox might consume 50 pounds of hay per day. Multiply that by 40 oxen over a 4-month logging season, and you were talking about hundreds of tons of feed that had to be purchased, transported, and stored. The oxen themselves represented a significant capital investment. A trained team of oxen might cost $100 or more. Their short working lives meant constant replacement costs. A big wheel rig was expensive to build, perhaps $300 to $500 depending on size and construction, but it did not eat. It did not get sick. It did not die and need to be replaced every 2 or 3 years. The horses that pulled the wheels still required feed and care, of course, but 4 horses consumed far less than 40 oxen. The economies of scale worked in favor of the new technology at every level. But the numbers only tell part of the story. To really understand what these wheels meant, you need to picture what they look like in operation. Imagine standing in a Michigan pine forest in the winter of 1885. Snow covers the ground, the air is so cold it hurts to breathe, and through the trees, you hear something coming. First, you hear the horses, the jingle of harness bells, the crunch of hooves breaking through crusted snow, the occasional snort and blow of animals working hard in the cold. Then you see them. 4 massive draft horses, each weighing close to a ton, pulling in matched pairs. Their breath steams like locomotive smoke. Their muscular bodies strain against the traces. Their hooves, fitted with sharpened calks to grip the icy ground, punch through the snow crust with each step. Behind them, the tongue of the big wheel rig extends back 10 feet to the axle. And then you see the wheels themselves. They are enormous. Each one stands taller than a man on horseback. They are painted red, the traditional color of logging equipment, though the paint is scored and battered from use. The iron tires are 4 inches wide, leaving tracks in the snow like the passage of something prehistoric. Between the wheels, suspended from the axle by heavy chains, hang the logs. 3 of them, each 20 feet long, each weighing perhaps 4,000 pounds. Their front ends ride 6 feet off the ground. Their back ends drag behind, cutting trenches through the snow. The total load approaches 6 tons. The noise is tremendous. The wheels groan on their axles. The chains creak and rattle. The logs bang against each other as the rig negotiates the uneven terrain. The horses blow and stamp. The teamster calls out commands, his voice hoarse from shouting over the din. And the whole contraption moves through the forest at something close to walking pace, navigating between standing timber, rolling over stumps, crossing frozen streams on reinforced bridges built specifically to handle the weight. This is what replaced 100 oxen. This is what changed logging. The men who operated these rigs were called wheel teamsters, and they were considered the elite of the logging workforce. It took genuine skill to handle a big wheel rig. The equipment was unforgiving. The stakes were high, and the margin for error was essentially zero. The wheels themselves had no brakes. Once the load started moving, the only way to stop was to turn the horses in a circle or find level ground where momentum would dissipate naturally. On flat terrain, this was manageable. On slopes, it became a matter of life and death. The teamster rode on a small platform mounted between the wheels, just behind the axle. From there, he could see ahead to direct the horses and behind to monitor the load. He controlled the horses through voice commands and long reins that ran forward along the tongue. His hands were never still, constantly adjusting, constantly compensating for the motion of the rig. On downhill runs, wheel teamsters faced a constant danger. If the load gained too much speed, it could override the horses, pushing them forward until they lost their footing. The massive wheels would roll right over the animals, crushing them, and continue on downhill until something stopped them. That something might be a standing tree. It might be a ravine. It might be another work crew. Men died this way. Horses died this way. The runaway load would crash through the forest. When smashing everything in its path until it hit something large enough to stop it, or the terrain leveled out enough for friction to slow it down. The best wheel teamsters developed an almost preternatural sense of the terrain. They knew exactly how steep a grade they could safely descend. They knew when to unhitch the horses and let them walk alongside the rig while gravity did the work. They knew how to use rough ground and fallen branches as natural braking surfaces. Some of them developed techniques for slowing loads on steep terrain. They would wrap chains around the wheels, locking them so they would drag instead of roll. They would attach trailing logs that acted as anchors. They would use long cables to lower loads down particularly steep sections while the horses waited at the bottom. All of this required skill, experience, and a deep understanding of physics that none of them would have described in those terms. They knew what worked because they had seen what happened when it did not work. They had buried friends who misjudged a grade or trusted equipment that failed, and they were paid accordingly. A skilled wheel teamster in the 1880s might earn $3 a day, nearly double what a common laborer made. The best of them were recruited aggressively, offered bonuses, treated with respect that was rare in the brutal hierarchy of the lumber camps. These were not soft men doing comfortable work. They spent their days in temperatures that could drop to 30 below zero. They handled equipment that weighed tons. They worked with horses that could kick or bite or simply lose their footing on icy ground and drag a man down with them. Their hands were permanently calloused from handling chains and leather. Their backs ached from the constant vibration of standing on the moving rig. Their lungs burned from breathing frozen air while exerting themselves at maximum effort. They lived in bunkhouses where 40 men slept in close quarters, sharing lice and tuberculosis and influenza. And they died. Make no mistake about that. A wheel teamster named Patrick Sullivan died in Osceola County in 1888 when his rig overturned on a steep traverse. The axle caught him across the chest. He lived for 3 hours, long enough to dictate a letter to his mother in Ireland, before the internal bleeding finished him. He was 26 years old. James Whitmore lost both legs below the knee when a log shifted during loading and the big wheels rolled backward over him. The wheels, weighing over 3 tons each, passed over his legs just above the boots. There was nothing left to save. He survived after a fashion and spent the rest of his life as a cook in the same camps that had crippled him. He lived another 37 years, making breakfast and dinner for men who did the work he could no longer do. Samuel Trent was crushed against a standing pine when his horses spooked at a falling branch and the rig jackknifed. They found him still alive, pinned between the wheel and the tree, but there was nothing to be done. The rig was too heavy to move by hand, and by the time they organized a second team to pull it free, he had been dead for an hour. His wife received the news by telegram 3 weeks later. She had their first child 4 months after that. That child never knew his father except through stories. These were not unusual deaths. They were the background noise of the industry. Every logging season brought its casualties, and the big wheels, for all their efficiency, added their own category of ways to die. The physics of the situation made certain accidents inevitable. A 6-ton load rolling on 10-foot wheels has enormous momentum. It cannot stop quickly. It cannot turn sharply. And when something goes wrong, the energy has to go somewhere. Usually it went into wood and metal and human flesh. Still, the wheels spread. From Michigan, they migrated west to Wisconsin and Minnesota. They appeared in the pine forests of the Adirondacks. They showed up in the hardwood stands of Appalachia. Wherever there was heavy timber and rough terrain, wherever the old methods of ox-powered skidding had reached their practical limits, the big wheels offered an alternative. And different regions developed their own variations. The northern wheels, built for deep snow and extreme cold, featured wider tires to reduce sinking. The eastern wheels, used in hillier terrain, often included primitive braking systems that could be engaged on steep descents. These might be nothing more than a lever that forced a wooden block against the tire, creating friction to slow the roll. The southern wheels, working in warmer climates without the advantage of frozen ground, sometimes used metal tracks beneath the axle to reduce the weight bearing on the dragging logs. By 1890, there were an estimated 3,000 big wheel rigs operating across the American timber industry. Some operations owned dozens of them. A large lumber company might have an entire division dedicated to wheel maintenance and repair, with specialists who could rebuild a damaged axle in the field or replace a cracked spoke without returning to the main shop. And the wheels had spawned an entire support industry of manufacturers, repair specialists, and the specialized teamsters who knew how to handle them. There were wheel makers in Michigan, Wisconsin, Pennsylvania, and Oregon. There were companies that did nothing but forge the massive axles. There were harness makers who produced the specialized equipment needed to control 4-horse teams pulling 6-ton loads. The original overpack design had been copied, modified, and improved by dozens of competitors. Some built lighter wheels for smaller timber, others built heavier rigs for the giants of the Pacific Northwest. The basic principle remained the same, but the variations were endless. And then, just as the big wheels seemed to have conquered the industry, something else came along. Steam power arrived in the forests. The steam donkey, first developed in California in the 1880s, offered a radically different approach to moving timber. Instead of animals pulling loads across the ground, a stationary steam engine would reel in logs on heavy cables. The engine sat in a clearing, perhaps a quarter mile from where the logs were cut. Cables ran out to the felling site. Workers attached the cables to freshly cut logs, and the steam engine, burning wood cut from the very forest it was harvesting, reeled in the cables and dragged the logs toward itself. The logs could be dragged straight up hillsides that no animal team could climb. They could be pulled across ravines on cable systems that eliminated ground contact entirely. They could move at speeds that made horsepower look primitive. The first steam donkeys were crude machines. They broke down frequently. They required skilled operators. They started fires if not carefully managed, and forest fires started by logging equipment killed more than a few operators over the years. But they also moved timber at rates that the big wheels could not match. Steam donkeys did not replace the big wheels immediately. For years, the two technologies coexisted, each suited to different terrain and different logging operations. The big wheels remained dominant where the ground was relatively flat and the distances relatively short. A wheel rig could navigate forest trails too narrow for cable systems. It could work in areas where setting up a steam donkey would take more time than the operation was worth. Steam donkeys took over the steep mountain logging of the West Coast. The Douglas fir forests of Oregon and Washington grew on terrain too rugged for wheeled equipment of any kind. The logs were enormous, far larger than the eastern white pine, and the hills were practically vertical. Only cable systems could extract timber from those conditions. But the writing was on the wall. Logging railroads pushed deeper into the forests, bringing a level of efficiency that neither big wheels nor steam donkeys could match. A logging train could carry more timber in a single trip than a fleet of big wheel rigs could move in a week. The investment required was enormous. Rails and locomotives and rolling stock cost fortunes. But for large operations, the math was overwhelming. A railroad could move timber from the cutting site to the mill in hours instead of days. It could operate year-round. So not just during the frozen winter months when skid roads were usable, it could access timber stands that would have been economically unreachable by any other method. The big lumber companies built thousands of miles of logging railroad in the decades around 1900. They laid track into valleys that had never seen wheels of any kind. They bridged rivers and cut through mountains to reach timber that previous generations could only look at. By 1910, the big wheels were already becoming obsolete in many regions. The old-growth forests of the Lake States were largely cut over. The endless stands of white pine that had fueled the industry for decades were mostly stumps now, hundreds of square miles of devastation that would take a century to recover. The industry was moving west, where terrain favored cable systems and railroad logging. The draft horses that pulled the big wheels were expensive to maintain, and internal combustion was beginning to offer alternatives. The first logging trucks appeared around 1910. They were primitive by modern standards, barely more than modified automobiles with flatbed attachments, but they could travel on roads that already existed. They did not require the construction of rails or the infrastructure of a railroad system. They pointed toward a future where timber could move on rubber tires at highway speeds. By 1920, the big wheels were clearly on the decline. New operations did not buy them. Existing wheels wore out and were not replaced. The specialized knowledge of wheel teamsters began to disappear as the men who possessed it aged out of the workforce, and nobody trained their replacements. By 1930, the big wheels had essentially disappeared from commercial logging. A few survived in small operations in remote areas where the terrain suited them and modern equipment could not reach. Some Amish communities in Pennsylvania and Ohio continued using horse-powered logging equipment long after the mainstream industry had abandoned it. But the era was over. The wheels that had once seemed like miracles of engineering were now relics, rusting in abandoned lumber camps, slowly being reclaimed by the forests they had helped to harvest. Here is what I think about when I consider the big wheels and what they represent. They solved a problem. They solved it brilliantly, in a way that transformed an industry and made possible the harvest of timber that built cities across America. The lumber that framed houses in Chicago and Denver and San Francisco, the boards that decked ships and planked sidewalks and lined the walls of 10 million rooms, much of that lumber moved through forests on big wheels. The men who invented them and the men who operated them contributed something real to the construction of this country. But they also disappeared completely. Within a generation of their peak, they were gone. The steam donkeys replaced them, and then the logging trucks replaced the steam donkeys. And now most timber moves on highways in ways that bear no resemblance to anything that came before. This is what progress looks like. Not a straight line from primitive to advanced, but a constant churn of technologies appearing, dominating, and vanishing. The big wheels had their moment. They were the best solution to a specific problem at a specific time. And when the problem changed, when the parameters shifted, when new tools became available, they became obsolete. The men who operated them vanished too, in a sense. Not literally, obviously. They found other work. They drove trucks or operated machines or left the timber industry entirely. But the specific skills they had developed, the knowledge of how to handle a 6-ton load on 12-foot wheels, the ability to read terrain and manage horses and survive the daily risks of the work, when all of that expertise evaporated. It was not passed down. There was no one to teach it to. The knowledge died with the last generation that needed it. Today, there are a handful of big wheels surviving in museum collections. You can see them at forestry museums in Michigan and Wisconsin, massive iron-tired relics that seem almost impossible to believe. Standing next to one, looking up at a wheel that towers over your head, you can begin to understand the ambition and the desperation that created them. The ambition to move what could not be moved. The desperation to find any way, any method, any technology that could extract the incredible wealth locked in the American forests. You can try to imagine what it felt like to stand beside one of these wheels when it was new. Fresh paint, gleaming iron, the smell of axle grease and horse sweat, the sound of chains clanking as a load was secured, the shouts of teamsters and the stamping of horses ready to work. You can try to imagine walking behind one of these rigs as it moved through the forest, the ground shaking slightly with each rotation of the massive wheels, the logs creaking against their chains, the constant awareness that tons of wood and iron were rolling just feet away from your body, perfectly capable of crushing you without even slowing down. You can try to imagine the exhaustion of a 10-hour day in the cold, on handling equipment that wanted to kill you, surrounded by men who might die at any moment from 100 different causes, the relief of reaching the camp at nightfall, the simple pleasure of hot food and a dry bunk, the knowledge that you would do it all again tomorrow. But you cannot really know it. That experience is gone. The men who lived it are dead. Their skills died with them. All that remains are the machines themselves, preserved in museums as curiosities from another age. The men who built these wheels were not romantic figures. They were not environmental stewards. They were not preservationists. They were participants in an industry that leveled entire ecosystems, that stripped the northern forests to bare earth, that left behind a landscape of stumps and slash, that took generations to recover. The logging industry of the late 1800s operated without any concept of sustainability. The idea of managing forests for long-term production simply did not exist. And the goal was to extract every tree worth harvesting as quickly as possible and then move on. When a region was logged out, the companies simply packed up and relocated to the next stand of virgin timber. They left behind empty towns and unemployed workers and devastated landscapes. The big wheels were tools of that extraction. They made it possible to log faster, to reach timber that would have been inaccessible otherwise, to accelerate the destruction. The results were visible for decades. Photographs from the early 1900s show Michigan and Wisconsin landscapes that look like the aftermath of a war. Miles of bare ground covered with stumps and branches, slash piles rotting in the sun, rivers choked with sawmill waste, towns that had sprung up to support logging operations standing empty after the trees were gone. But the men who did this work were also engineers, problem solvers, innovators. They looked at a challenge that seemed impossible and built a solution out of iron and oak and muscle. They did what humans do. They found a way. This is the tension at the heart of the story. The same ingenuity that made it possible to build the big wheels also made it possible to clear-cut an entire region in a few decades. The same drive that pushed Silas Overpack to solve the problem of moving heavy timber also pushed lumber companies to harvest every tree they could reach without regard for what would come after. We are beneficiaries of that ingenuity. The cities built with that timber still stand. The houses framed with Michigan pine still shelter families. The industries that grew from the wealth extracted from those forests still employ millions of people. We live in the world that logging built. We are also inheritors of the damage. The old-growth forests are gone. The ecosystems they supported are impoverished. Species that depended on those forests have disappeared or declined. The scars on the landscape, though healing, are still visible if you know where to look. You cannot separate the good from the bad. You can only try to understand what happened and why. You can only try to see the people who did this work as human beings responding to the circumstances of their time. They were not villains. They were not heroes. They were workers doing what they were paid to do, using the best tools available to them. The big wheels were one of those tools. For 40 years, they were the best answer to a specific question. How do you move a 5-ton log through a trackless forest? You build wheels big enough to lift it off the ground and roll it to where it needs to go. The forests of Michigan are returning now. Second growth and third growth cover the land that the big wheels help to harvest. The white pines are mostly gone, replaced by mixed hardwoods that would not have been there if the original canopy still stood. Maple and beech and birch grow where the great pines once blocked the sun. The ecosystem is different, simplified in many ways, but alive. Deer browse in stands of aspen and birch that grew up after the original forest was cut. Ruffed grouse thrive in the young growth that the old-growth pines would have shaded out. The land is not what it was, but it is recovering. It is becoming something new. And somewhere in that forest, buried under decades of leaf litter and soil accumulation, there are probably still traces of the old skid roads, the parallel depressions where logs were dragged, the occasional rotted crosspiece of a corduroy path, the ghost infrastructure of an industry that transformed the landscape and then vanished. If you walk in these forests with eyes trained to see, you can find evidence of the logging everywhere. Enormous stumps from trees cut 130 years ago, still resisting decay because the resin in old-growth pine preserves them. Rusted cables from steam donkey operations, half buried in the duff. The rectangular depressions where bunkhouses once stood, now filled with ferns. The big wheels rolled through these forests for perhaps 40 years. 2 generations of men learned to operate them, and then a third generation found better tools and moved on. The wheels were scrapped for their iron, or left to rot in abandoned camps, or occasionally preserved as curiosities. 100 oxen could move a load of timber through a Michigan forest in 1870. A pair of horses and a set of big wheels could move the same load faster and more efficiently by 1880. A steam donkey could move it faster still by 1900. A diesel truck can move it faster yet today. This is progress. This is what it costs. This is what it leaves behind. The wheel teamsters are all dead now. The last of them passed away decades ago, taking their skills and their stories with them. Patrick Sullivan, who died on that steep traverse in 1888, left no descendants. James Whitmore, the cook with no legs, was buried in an unmarked grave. Samuel Trent, crushed against the pine, and has no memorial except perhaps a weathered headstone in a small town cemetery that nobody visits anymore. Their work is forgotten by almost everyone. The transformation they participated in has receded into history. If you asked 100 people how timber was moved in the 19th century, probably none of them would mention the big wheels. The technology is too obscure, too specific, too thoroughly superseded to register in popular memory. But the cities they helped to build still stand. Where the houses framed with Michigan pine still shelter families. The industry they served, for all its destruction, created the material foundation of American expansion. The 30-ton wheels replaced 100 oxen because someone looked at an impossible problem and refused to accept the limitations everyone else had accepted. That is the human story, for better and for worse. We find ways, we build things, we transform landscapes, and then we forget what they looked like before. The big wheels are gone, the forests are returning, and somewhere in the turning of that cycle, there is something that might be called progress, or might just be called time. If you have watched this far, you understand something about the forgotten technologies that built this country. There are more stories like this one. Machines and methods that dominated their era and then disappeared so completely that nobody remembers them. Click the video on screen now to see another one. The technology that made the big wheels possible in the first place. The Industrial Revolution in miniature, playing out in the forests of the American frontier. And if this is your first time here, consider subscribing. This is what we do. We dig up the buried history of how things actually got built. The tools and the workers and the impossible problems they solved. I will see you in the next one.